Well, hello. So we're here today and we're going to be talking about two things. One, vector diagrams, and then also going to quickly show you a brief introduction to distance versus time graphs, velocity versus time graphs, and acceleration versus time graphs. So the first thing we'll discuss here is vector diagrams. And it's useful to first start thinking about some dot diagrams. At this point, we should be somewhat familiar with these. And we know that this represents sort of what's happening at 0 seconds, 1 second, 2 seconds, 3 seconds, 4 seconds. Let's say another scenario, something is happening, another dot diagram, and you would see something like this, where you'd have 0 seconds, 1 second, 2 seconds, 3 seconds, 4 seconds. Likewise, you could have something similar, only it would look like this. Where again, 0, 1 second. Each of these scenarios, something's been dropping, oil drop, that represents motion over a period of 4 seconds. Well, we want to go back to the idea of vector diagrams, and the thing that we're talking about here is, remember, there's two different quantities. We talked about scalar and vector, and so a vector, if you remember, and of course velocity is a vector. A vector is something that has a size, or we've used the word magnitude, and direction. Size and direction. Now, arrows are very often used to show vectors. And so what I would like to show you here is, if we were going to use an arrow to show a vector, an arrow to show velocity, what would that look like? So if we jump over here, if we would show velocity as this arrow, we would take a look at this, and you'll notice that the arrow that we're using to show the vector is pointing that way, and it's staying the same size. So velocity is staying the same size and the same direction, so we can see that the vector or the velocity is staying the same. Likewise, we could do that down here. If we showed velocity as an arrow, we would show the direction of this arrow is staying the same. But in fact, the vector that would be representing velocity is getting longer, so velocity is increasing, which means the object is speeding up, and it's going this direction. The direction staying the same, and acceleration would be in this direction. Down here, we could also make a vector to show what's going on with velocity here, and we can see velocity is not changing, but this vector diagram would show that the velocity is getting smaller with each passing second. So if we then think about another vector quantity, we'll go light blue. Hey, I'm back. We could say acceleration. Is another vector quantity, and it has a size and a direction. And we could look up here, and if we were going to draw an arrow that shows this acceleration, well, velocity is not changing, so there actually is 0 acceleration up here, so there would be no vector we could show down here. But that's not the case on these two. These two both have an acceleration, and so in this case, the object is speeding up as it goes this way, so we know the vector would be this direction. So if we were to draw that, it might just be an arrow that would look like this. But here's where it gets a little funky. I gotta be careful when I draw this. The acceleration for this one would be staying the same. It's in this direction. Acceleration is in this direction. But acceleration is staying a constant amount if this object was accelerating at a constant rate, which is what we're trying to show here. So you see the vector is in that way, but it stays the same size, whereas the velocity vector is getting larger. Likewise, down here, the object moving this way, and this is perhaps the most difficult one for some folks to wrap their mind around. The object is moving this way. Arrow is moving this way. but it's slowing down. So the acceleration is actually happening in the opposite direction. So what that would look like is the arrow that shows direction is pointing the opposite direction. Now notice I was trying to model this as being approximately the same size. Obviously the amount or the magnitude of acceleration would determine the length of the arrow. But what I'm trying to show is acceleration is happening in the opposite direction as the velocity. So in this case we would see it slowing down. And a general rule of thumb is if it's speeding up, if the speed is increasing, if it's speeding up, acceleration and velocity are in the same direction. If it's slowing down, velocity and acceleration are in opposite directions. And so that is the extent of vector diagrams. In my next video, I will discuss those three types of graphs.